Okay, managerial economics. I suppose you know it is directly related with microeconomics. I'm going to use the Breutigams microeconomics for the managerial economics, and today I will give you the first chapter. The outline for the course today, microeconomics modeling, is going to be introduced to you, the elements of the models, solving the models, and the limits of the microeconomic analysis or analysis. And then we will go into the microeconomics modeling on three analytical tools: the constraint optimization, equilibrium analysis, and comparative statistics. I suppose you know some little bit the constraint optimization, which is related with the budget constraint. And then equilibrium analysis is also related with the tables and the graphical analysis. And the comparative statistics is also given for the comparison between the data, which is going to be introduced to you in this class. The exogenous and endogenous variables, I suppose you know from your mathematical courses. We are using the endogenous variables, which is on the left side of the equation, and the exogenous variables on the right side of the equations. And when you are creating a model, it is important to know which variable is affecting and changing what. And usually the exogenous variable is going to be used for affecting and changing the endogenous variables. For example, when we are going to concentrate it to the demand equation, Q is equal to A minus BP. As you know, Q is the quantity, A is the intercept or the, let's say, coefficient, and minus BP is the variable and the coefficient for the slope of this linear equation. And P is the price. As you know, the demand equation and the demand curve is dependent to two variables, the quantity and the price from your economics classes. And this is affecting and changing sufficiently the price changes will be will affect the quantity sufficiently. Therefore, price here is the exogenous variables, and the quantity, which is on the left side of the equation, is the endogenous variable. Any model, whether it is used to study chemistry, physics, or economics, must specify what variables will be taken as a given in the analysis and what variables are to be determined by the model. The exogenous variables, a variable whose value is taken as given in the analysis of an economic system, and endogenous variable, a variable whose value is determined within the economic system being studied. The constraint optimization, which is the first, let's say, phase of this analysis for the models, is the budget constraint that we are concentrating for the equations. Constraint optimization problems usually have two parts: the objective function and a set of constraints. Let's look at it. We are supposing a simplest model here and simplest example for being able to understand how we are going to create a model and how we are going to analyze any let's say given problem. Here it is suppose a farmer plans to build a rectangular fence as a pen for his sheep. He has F feet of fence and cannot afford to purchase more. And however, he can choose the dimensions of the pen, which will have a length of L feet and width of V, or so-called W feet. He wants to choose the dimensions L and W that will maximize the area of the pen. He must also make sure, that the total amount of fencing he uses the perimeter of the pen does not exceed F feet. The problem here, what is the objective function for this problem? What is the constraint? And which of the variables in the model L, W, and F are exogenous and which are endogenous, going to be explained to you for being able to understand the model and the components of the model, how it is going to be created and what is going to be used for the affection of each others in a given model. The solution, the objective function, is the relationship that the farmer is trying to maximize, in this case, the area, length, and width, which is L and W. In other words, the farmer will choose L and W to maximize the objective function of the L and W, so-called length and width. B, the constraint will describe the restriction imposed on the farmer. We are told that the farmer has only F feet of fence available for the rectangular pen. The constraint will describe the restriction that the perimeter of the pen is going to be created for the equation 2L plus 2 wide, so-called 2 length plus 2 wide, must not exceed the amount of fence available for the F. Therefore, the constraint can be written as an equation 2L plus 2W must be less than or equal to the F, so-called the fence, which is going to be bought by this person. Up to now is okay? You are understanding? Do you have any question, please? You can speak to me, no problem. Do you have any question?
Yes.
Is that okay? You are following me?
Yes, sir. What are the significance of the 2L and 2W? Are they just variables or they are
Yeah,
standard
these
equation?
These are the variables which is going to be used for this simplest example. And L is the length and width, W is the width, which is supposed to be the rectangular fence is going to be used for this problem. And the F is the fence, the meter of fence, which is going to be bought by this farmer for creating this, let's say, rectangular area for the sheep. Okay, this is the constraint analysis. The constraint optimization, so-called the budget constraint, is going to be introduced to you in the following slides. The farmer is given only F feet of fence to work with. Thus, the perimeter F is an exogenous variable, isn't it? Since it is taken as given in the analysis, the endogenous variable are L and W. Since the values can be chosen by the farmer as it is given, determined within the model. So when we are going to summarize the given, let's say, information, what is the maximum length and width for this given model? And the endogenous variable is supposed to be length and width, and exogenous variable is the fence, so-called the F. Therefore, the subject here for this equation is 2L plus 2W must be equal or less than this fence, which is going to be bought by this farmer. These three steps must be done for being able to solve such questions and such, let's say, model, such simple model. Then the objective function, as you are understanding, specifies what the agent cares about and what to optimize. Example, a consumer cares about maximizing his satisfaction, and the manager cares about rising profits, reducing costs, and increasing power. This is the given another example for the objective function. The constraint here given, the definitions, limits placed on the resources available to the agent. An example is given, the manager budget is $1 million, sorry, euro, and the consumer income is 3,000 euro. Therefore, the behavior of an agent can be modeled as optimizing the objective function subject to his various constraints. The example is then given here, the consumer purchases, which is given in the former model for the fence, for the former, for rectangular fence. The consumer here, an ordinary consumer, choose the scenario is given here two, let's say, article, food and clothing. Food is represented with F and clothing is represented with C, and take as given in his income as I, which is the disposable income. The price of the food is then PF, and the price of the clothing is then PC. The satisfaction from purchases is supposed to be S, which is the utility function used, is supposed to be F multiplied with F, will be in the square root. Then the objective function, then maximizing satisfaction, will give then F multiplied C is in the square root. Therefore, the subject to this equation will be then PF, so-called the price of the food, multiplied with the food amount, plus price of the cloth will be multiplied with the clothing amount, must be less than or equal to the income of this consumer. Is it clear here? Up to here. Then when we are going to constrain the example on the table, on the graph, sorry, then the graph for the budget constraint will be represented as a linear equation as it is given here, a line, linear graph and line as it is given. On the vertical axis, we put the food, and on the x-axis, we put the clothing. And since we know that the budget is limited with the amount of the income for this consumer, then we have to put this price and food amount and price and cloth amount supposed to be equal or less than this income, which is below or at least on this line, which is represented as the consumer budget constraint or budget line, so-called. Okay. Then when we're gonna put on this line, on this budget line, the indifference curve, I suppose you know the word indifference curve, what indifference curve is, and it is supposed where it is tangent to this budget line. This will then gives us the optimal bundle for this given consumer for being able to consume in a given scenario, which is supposed to be F multiplied C, will be in square root, supposed to be the utility function for the given consumer is composed or comprised regarding to this given budget line. Up to here is okay, you are understanding? Okay. And when we are going to reduce it to this indifference curve below to this budget line, you are observing the income is higher than this indifference curve, and at this scenario, in the second S0 satisfaction or utility curve, so-called indifference curve, we are not preferring to have any combination because our budget is more than this indifference curve. Therefore, we don't prefer this option for the given scenario because we suppose the maximum or optimal bundle for this or for given scenario must be tangent to the budget line, where the indifference curve is tangent to each other between tangent budget line and indifference curve should be tangent to each other. Then this will then gives us the optimal or maximum satisfaction for the consumer. And if it is above this budget line, this is then, as you are understanding, not available because the income capacity and the budget line for this consumer is less than in a given S2, so-called the utility satisfaction line or indifference curve. And this is then not also preferred because this is too high to reach for the given income level. Therefore, S2 is supposed to be more than S1, and S1 is supposed to be S0 in given scenario. And as I said to you, S1 is the best possible option for this consumer because it's better fitted to the budget line, and it is tangent to this budget line and should be maximizing the given scenario for this consumer. Another example, advertising spots. Suppose the manager of a beer company wants to decide the firm's advertising spots. The budget supposed to be 1 million euro to allocate between TV, so-called T, and radio R. The problem is the maximizing the TV and radio, which is going to be the better option for this company. The subject to be, again, we are going to create the budget constraint and budget line and budget equation. Then PT is the price of the television advertising, and T is the amount of the advertising which is in the television or will be in the television shown, and PR is the radio advertising price, and R is the radio advertising amount for this company, and it should be less than 1 million euro budget, or at least equal to this amount for being able to satisfy this company's advertising option, where B is the barrels and PT is supposed to be, and PR are the prices of the TV and radio advertising respectively, as I said to you. And here we are observing total spending, the new beer sales generated, supposed to be the company is selling beers, and on the TV it is supposed to be sold at 100, at zero is 0 and 0, of course, and at $100,000 or euro it can be 4,750 let's say dollar is going to be invested for the television, and 950 is going to be for the radio, and it goes like this. For the 200 it is approximately doubling it, 9,000, and it will then again somehow double it, then 1,800. As you see, as much as you are increasing, the utility function is decreasing. It is increasing actually, but it is decreasing. Amount of increase is realized as much as you are increasing the amount of the money which is going to be spent for this advertising. And when we are looking to the 500,000, somehow it is going to be 18,750, and it will be then 3,750. When it goes to 700,000, it is going to be 22.750 and 4,550. And when it goes to 900,000, it is then 24.750. Then it's going to, for the radio, 4.950. And for the 1 million, it is 25,000. And sorry, for the radio is 5,000 is going to be expected the amount of the sales realized regarding to this advertising. Therefore, you have to determine which option is better fitted to you or to your company for being able to determine the best possible option regarding to this budget line and budget constraint, I suppose to be the better estimation for the model. The equilibrium analysis, when we are going to use for analyzing any given scenario, we are using the table, we are using the graphic, sorry, for analyzing the given, let's say, scenario or models. The equilibrium, as it is as a definition, is a state that will continue indefinitely as long as the exogenous factors remain unchanged. As it is given here, the supply and the demand will be then price and the, let's say, white so-called, or let's say any price which is going to be used for the coffee beans, and demand is then represented on the inversely proportional graph line between price and quantity. Therefore, the equilibrium realized here, as you are observing, where the P star and Q star is intersecting each other on these two lines where the supply and demand curves intersecting and having the equilibrium position. And in this example, equilibrium is defined as the point where demand equals supply in the market, and the point where the demand and supply curves crossing each other is supposed to be the best possible, of course, option. Above is the surplus, and below of this curve, as you are understanding, is the scarcity. Therefore, we are always trying to approach to the equilibrium position for being able to get the best possible marketing option for the coffee beans, which is given in the scenario. And the comparative statistics, yes, please. I'm listening.
Please. Yes, we go back to the table.
This one.
No, sir.
Table. This
Wow.
one.
Yes, sir.
Yes, please.
That we want to know the best combination.
The best combination, as I said to you, it is depending to your preferences. Here, it is not easy to determine which better, because you have to look the sales, isn't it? You investing 100,000 and you are selling 4,750 and the other one is 950. It is depending to your rivals also here, as in the other cases also. It is depending to your capacity to spend this money. As much as you are increasing the spending for advertising and the sales is increasing, but as you see, it is decreasing amount of increase is realized, isn't it? Therefore, you have to draw the graph to see which better option or which option will be the better fitted to your preferences. Therefore, you are not easily determine which option is going to be the best possible preferences for you, because we don't know your rivals and we don't know which one is going to be better fitted for your preferences. Therefore, table analysis is always risky. You have to use some more other options for being able to determine the best possible, let's say, option, because there isn't any marginal utilities or any additional combination for given scenario. We have to calculate it, which will be later in the coming lessons, is going to be introduced to you in the production function. Then you will understand better how you are going to analyze the tables, because this is the first class and first table and first lesson. And on this table, it is not easy to show you everything. You have to, this is only to show you, we have two options to make some models. Either we are going to use the equations, we are going to use some calculations, isn't it? To analyze, or you're going to use some tables to see what option is going to be better fitted to you, which is here not everything is shown, because this is the first lecture. We have to show you the production function, show you the additional units which is going to be added. As you are understanding marginal units, the diminishing returns must be given, and what is the combination of this scenario must be shown to being able to understand and analyze, and the better, let's say, combination then determined. And here the equilibrium analysis, as I said to you, is going to be introduced to you. This is the lecture for showing you what analysis you can do for being able to determine the company's profit or company's better off position. You are understanding? Therefore, we are not able to make a realistic analysis and estimation with this given, let's say, information. We are just only introducing you the options that you are going to use for analyzing the, let's say, firms and companies, let's say, profit, or let's say their sales. Okay?
Okay, sir.
Okay. Thank you for your attention. And the example, as I said to you, the equilibrium is defined as the point where the demand equals supply in the market, and the point where the demand and supply curve are crossing each other. And the comparative statistics, as I said to you, is the analysis compares the equilibrium state of the system before change in the exogenous variable to the equilibrium state after the change. The comparative statistic, as I said to you, the analysis used to examine how a change in some exogenous variable will affect the level of some endogenous variable in an economic system. As going to back this, let's say, graph, the coffee beans is given supply and demand, and quantity, pounds, and price is also on the vertical, and the intersection is also given. Suppose it is shifted the new supply to the right, and it is somehow, as you are observing now, the demand is little bit supposed to be expanded. Let's see, the price is reduced and the quantity demand is enlarged, as you are observing, isn't it? You see here, because somehow the demand is a little bit shifted to the right and the quantity sold is enlarged because the price is reduced. Because when the price is down in the seasonal, let's say, discounts, we are also enjoying to shop more. And the people in the market is always more crowded and they are buying too much. When the price going up, we don't. On the example again, when we're going to flash back the budget constraint and constraint analysis and estimations, the budget line is given again here. The PF plus PC is equal to I, as you know, the price of the food amount plus price of the cloth amount is equal to the disposable income for a given consumer. And it should be intersect each other, we said. And if it is down because any unexpected, let's say, inflation or unexpected income reduction, then we have to reduce and shift our, let's say, budget constraint and maximum or optimal bundle to the lower level where it is indicated in this scenario at S1, where the food and clothing root scale is the equation for this utility function, where the indifference curve intersect the second, or so-called the I1 income level, where the I0 is a little bit more. And from this point of view, we are understanding S0 is more than S1 and I0 is more than I1 at a given scenario. The positive normative analysis, when we are looking, the positive analysis can explain what has happened due to an economy policy, or can predict what might happen due to an economic policy. And normative analysis is an analysis of what should be done. So it is a little bit different, as you are understanding. The one is going to be what has happened in the positive, and in normative, what should be done is somehow the political changes expected, or something that you are going to rearrange for doing something, for preventing or for managing something. The positive analysis that attempts to explain how an economic system works or to predict how it will change over time. And positive economics is a stream of economics that focuses on the description, quantification, and explanation of economic developments, expectations, and associated phenomena. A normative analysis that typically focuses on issues of social welfare, examining what will enhance or detract from the common good. And the normative economics focuses on the ideological, opinion-oriented, prescriptive, value judgments, and what should be statements aimed towards economic development, investment projects, and scenarios. The positive statement and positive reasoning more generally are objective, as such they can be tested. These fall into two categories. One is the hypothesis, like unemployment is caused by a decrease in the GDP. This is positive. A normative statement is one that makes a value judgment. Such a judgment is the opinion of the speaker. No one can prove that the statement is or is not correct. Here are some examples of normative statements in economics. We ought to do more to help the poor. People in the United States should save more for retirement, and corporate profits are too high. Or you may say we have to open more factories for reducing the employment, so unemployment, or this kind of judgment, or let's say statement, is normative. And the other one, where you are going to just only give some information about the existing conditions, is the positive statement. I hope you are understanding what I am telling you. And the positive statement deals with the assumptions about the state of the world and some conclusions. The validity of a positive statement is verifiable or testable in principle, no matter how difficult it might be. Example 1, if it is given, the weight of the earth is 6 septillion, 6 times 10 power of 24 metric tons. Example, an increase in the minimum wage increases unemployment among teenagers, which is expected. And normative state, because you don't have to do anything here, but normative statements against to this, you have to do something. You have to rearrange something. Contains a value judgment. They contain words such as have to, ought to, must, should, or non-quantifiable adjectives such as important that cannot be objectively measured. Accordingly, normative statements cannot be verified by scientific methods. Example, at present, unemployment is a more serious problem than inflation. The tax rate on the, let's say, top earners more than 1 million euros should be 75%, which is supposed to be give some information about to do something. And the limits of the economic analysis, if it is going to be as an example,